In order to understand electrical theory, the first thing we have to do is get an understanding of triangles, more specifically the right triangle. To have an understanding of the right triangle, we have to go over Pythagoras' theorem. Pythagoras' theorem is a relation in Euclidean geometry among the three sides of a right triangle. It states that the square of the hypotenuse, the side opposite the right triangle, is equal to the sum to the squares of the other two sides. Okay, relax. It's not that difficult. Let's take a look at the way this formula looks. So with all that wording there, basically it's telling us that this guy, let's get my ink turned on here, a squared plus b squared is equal to c squared. What does that look like though? When we're talking about a triangle, let's get a triangle drawn up here. My thickness, there we go. Let's get this guy drawn up. Nice right triangle. Boom, boom, boom. Okay, let's give these sides the ABCs. This is A, this is B, and this is C. What this is telling me is if I take this side and square it, and add it to this side and square it, I'm going to get this squared. Alright, let's take some numbers and throw them at this so we can see what I'm talking about here. So let's make this side, say, 3, this side 4, and we're trying to solve for this side here. So this side we'll call A, this side we'll call B, and we're trying to solve for C. So if we know that A squared plus B squared equals C squared, let's see how these look. I've got 3 squared plus 4 squared is equal to C squared. Now we've got 3 squared plus 4 squared, let's turn those into numbers we can use. 9 plus 16 is equal to C squared. So far so good. Which, again, let's take it down one more. 9 plus 16, you should be able to do this in your head. 25 equals C squared. Okay, we still have an issue though, because we haven't solved for C yet. We just have C squared. C squared equals 25. So let's move this guy up out of the way. Move him up over there. Now, if we want to get C alone, what we have to do is we need to square root to get rid of that square. I need to get rid of that guy there. In order to do that, I have to square root the C. Whatever I do to this side of the formula, I have to do to that side of the formula. So the way that looks is C is now equal to the square root of 25. Well, if you punch in your calculator 25, then C is equal to 5. And we've just solved for our hypotenuse there, or that long side, the C side that we're looking at. So coming back to our triangle here, we don't need this little question mark anymore because we know what it is. We've solved and determined that if we take this guy here, which was 9, plus this guy here, which is 16, they gave us 25 on this side, but then that was C squared. So we have to get rid of that. We square root that, which means we square root the 25, and we end up with an answer of 5. And we've solved for C. So when we're using Pythagoras, it doesn't really matter about the A or the B, where they are. I mean, it could have A and B like that, or I can, let's get rid of that guy and get rid of that guy. I could have B and A like that. Totally doesn't matter. The big thing is the C. The C is always that longest side. It is always the side, like I said earlier, that is opposite the 90-degree angle, which is this guy right there. So, that being said, what happens when I have C, let me just draw the C in there, and I have, say, B, and I need to solve for A? How is that going to work? So remember I said Pythagoras is A squared plus B squared is equal to C squared. And basically, if I wanted to get what C was, C is equal to the square root of A squared plus B squared. I think we can all remember that one. But what if I have C and I need to figure out, say, what A is? Well, it's not so hard either. Let's take a peek. Starting with our original formula of A squared plus B squared equals C squared. If we're trying to figure for B, all we have to do is we have to get rid of A. And the way we get rid of A is if we subtract it on this side, it'll get rid of it. If we subtract a on that side, then we're going to have to subtract it on this side as well. So what the formula is going to look like is b squared is equal to c squared minus a squared. So we're just subtracting it. And then again, just like we need to get rid of this little guy here, that 2. So again, we're going to have to square root this side. Whatever we do on this side, we have to do on this side, so we'll square root that side. So in order to solve for b, it looks like this. b is equal to the square root of c squared minus a squared. So let's throw some numbers at that now. Let's assign a number here. Let's just make something up. Let's say that this guy here, our c side, is going to be 20, and let's say this side is going to be 5, and we need to solve for that side there. So what we need to do is put that into our formula. Need to put this into our formula, so let's move this guy up here. Now again, if I go over here and take a look at what we're dealing with, 20 and 5, when you need to figure out what our a side normally would be. So let's go back here. So we've got to figure out what b is. We know that our c squared, so we know that b is equal to the square root of 20 squared minus 5 squared. So let's move this guy up now, and we'll break and figure out what this 20 squared is, and let's figure out what this 5 squared is. Just pull out my calculator, one sec. So we've got 20 squared is equal to 400, 5 squared is equal to 25, so b is equal to the square root of 400 minus 25. Therefore b is equal to the square root of 375, 400 minus 25. So let's move that up there, punch into the old calculator the square root of 375, and we end up with b is equal to 19.37. Make that point a little bigger there. And therefore we have figured out, that this side here is 19.37. So if you wanted to double check that, you could also just punch in your calculator 19.37 squared plus 5 squared, square root of that should give you 20, which it does. If you have any questions at all, please leave comments in the comment section or come see me in class. Good luck.